Okay, let's now move on to our next diagram. So that'll be this one over here. So let's copy that. Good. And here it is. Okay. So what do we have? Well, first of all, there are 5 lines. I think now you know how to count it. So this will be 1 over alpha to the 5. And there are 2 vertices. So we've got minus g squared and 4 factorial, which is 24 squared. Okay. And now let's again look at our Feynman rules and what is the list of things here? So we need 1/2 for each closed line. So how many closed lines are there? So there's one closed line over there. It has the same start and end point. There's another closed line over there. It has the same start and end point. And one more closed line over there, which has the same start and end point. So on this diagram, there's a total of 3 closed lines. So we will have 1 over 2 cubed. Then we can look for equivalent lines. Well, this line is equivalent to this line. The two of them have the same start and end points. So we've got 2 equivalent lines. So we'll have 1 over 2. This is for equivalent lines, and this is for closed lines. And then equivalent diagrams, no equivalent diagrams. Equivalent vertices, no, those 2 vertices certainly are not equivalent. So this is what we get. So let's add up what this diagram is equal to. Well, we'll get a g squared. We'll get an alpha to the 5. And then we've got 24 squared, and we've got 1 over 4 squared. Okay, that's 1 over 2 to the 4, which is 1 over 4 squared. 24 over 4 is 6, so we've got 6 squared, which is 36. So we'll have plus 36 g squared over alpha to the 5. Good. Okay, let's now move on to the next diagram. So let's just delete this. Delete, good. The next diagram will be this one. Duplicate, good. So let's put it over here. Again, I think that we've counted how many lines a number of times. So you can see on this diagram, you should be able to see that there are 5 lines. So this is 1 over alpha to the 5. How many vertices? There's 2 vertices. So we'll get a minus g squared and a 4 factorial over 24 squared. And now let's start counting. So we start off and we say, are there any closed lines? Well, yes. That line over there has the same start and end point, and that line over there has the same start and end point. So there's a total of 2 closed lines. So 1 over 2, and this is for closed lines. And then, are there any equivalent lines? No. There's no 2 lines on that diagram that have the same start and end points. Are there any equivalent diagrams? There is just one diagram. Are there any equivalent vertices? No. Those 2 vertices are distinguished by which dot they connect to. Okay? There's a unique vertex connecting to the left dot and a unique vertex connecting to the right dot. Oh, sorry. This should be squared because we had 2 closed lines. Okay, now 24 over 2 is 12, and 12 squared is 144. So for this diagram, we get plus 144 g squared over alpha to the 5. Okay, so I suspect by now you're really getting the hang of things. So let's move now to the next Feynman diagram. And that will be this one. Good. Okay. So let's work out the value of this Feynman diagram. Well, once again, there are 5 lines. I'm sure that you can easily see that. And there's 2 vertices, minus g squared and 24 squared. And then let's start to take a look. So how many closed lines are there? Well, there's only one line that starts and ends at the same point, and that's that line that I've shown in red. So we'll get a factor of 1/2 for the closed line. There's only a single closed line. And then what about equivalent lines? Well, that red line over there has the same start and end points as that green line over there. So there are two lines that are equivalent. So we should have a 1 over 2 factorial, which is just a 1 over 2. So 1 over 2, and this is for equivalent lines. Then how about equivalent diagrams? Well, there is just one diagram. And how about equivalent vertices? Well, those two vertices can be distinguished. Only one of them connects with the two dots, and only one of them has two legs closed into a loop. So there's no equivalent vertices. So if we work out what we get from this diagram, we've got plus g squared over alpha squared. And then we've got 24 over 2, which is 12, and 12 times 12 is 144. Okay, good. And I think there's only one more diagram to go. So let's evaluate the last diagram. So the last diagram is this one. Duplicate, good. Now, just by the way, physicists usually refer to this diagram as the setting sun diagram. So if you see people talking about the setting sun, this is the diagram that they mean. Okay, so what is this equal to? So there's 5 lines, so there's 1 over alpha to the 5. There's 2 vertices, so there's a minus g squared and a 24, because it's minus g 24 for each vertex. Then let's look at the factor. There should be 1/2 for each closed line. Well, there are no closed lines. There should be 1 over q factorial for q equivalent lines. Are there equivalent lines? Well, that red line has the same start and end points as that blue line, which has the same start and end points as that green line. So there are 3 equivalent lines. So we should get a 1 over 3 factorial. So 1 over 3 factorial for equivalent lines. Then how about equivalent diagrams? Well, there's just one diagram. And how about equivalent vertices? Well, each vertex connects to a different dot, so they definitely can be distinguished. 1 over 3 factorial is 1 over 6, 24 over 6 is 4, and 4 times 24 is 96. So we get plus g squared over alpha squared times by 96. Now we should add these up. This was the last diagram, so this is going to be the sum of the Feynman diagrams. And what do we want this to be equal to? Well, this should reproduce the order g squared term in the red box. So after we've added up all of these terms, we should get g squared over 2 times 945 over alpha to the 5. Sorry, guys, I don't know why I started to write alpha squares. I don't know if those are meant to be 5s, but they didn't look very 5-ish. And of course, they must be 5s. These last 2 diagrams here obviously have 5 lines. Okay, so please add those numbers up and let's see, do we get g squared over 2 times 945 over alpha squared? I'll check it, you check it, and we'll compare in the next recording.